Hello everyone, very good evening to all of you. Very good evening guys. How are you all doing at your ends? Very good evening everyone. How are you all? And like how is everything going at your ends? Just give me a minute na. I'll just open this chat. Okay, just allow me a second. And by the time like whosoever has joined us, drop me a hi in the chat box so that I just get to know you all here, and we'll be starting in for today. Okay, hey Harshit, very good evening, very good evening. Very good evening everyone. Perfect guys, perfect. So yeah, how are you all doing everyone? How is everything going at your ends? So we'll be keep on discussing about these things also, but yeah, before that I'll let you know right away what is going at Unacademy in terms and what are we exactly like offering you, okay? Okay, hi Isadya, hi, welcome to the session, okay? So you can join the Prarambh and the Vishwas batches for GATE and PSC 2025 and 26, which is going to start on 30th of December. You are having two kinds of subscription, the plus subscription and the iconic subscriptions, okay? So you get like the durations which you get over here are 12 plus 2 free months, and further you get 15 plus 3 free months, right? You get it 24 plus 4 free months. These are durations that you get up over here in terms of like what are the things and what is the duration for which your course is gonna be running, right? Now that's the thing. After that we are having up the total price and about the things also, right? So what you have to pay in terms of the amount of the courses which you want to enroll in and everything, like you have up over here all the details, right? So you can just look over them once. So like if for any other types of queries or the details, you can reach out to the number 8585 and you will be getting all of your details, all of your questions answered at that respective place. Just a second. Just let me check the camera once guys, just a minute. Okay, perfect. Right, so yeah, this is what we are having. And now I'll tell you about it, when are these batches are starting and what are the things we have for them. So it is going to start, the Prarambh batch is going to start for the GATE and PSC 2025 for the CS and IT, okay. It's going to start on 30th of December. You're having Hindi plus English, CS and the batch number B. This is right away what is exactly starting, okay. You'll be starting on the database management system for the SIMs. You can contact out 8585 and they will be getting all of your queries or the things whatever you are having, they'll be getting resolved over the same. Next is the Vishwas batch, which is for your GATE and PSC 2026 for the CS and IT. Again, it's going to start from 30th of December. Hindi plus English, CS and the batch number B. So you'll be starting on the database management system again with the same thing until 30th of December. Then we are having the Prarambh batch for DS and AI. Also the Prarambh batch for the GATE and PSC 2025 for DS and AI. It is also starting on 30th of December. It's going to be Hindi plus English, DS and AI, and that will be a batch number A. Okay. So that will be your database management systems. And further talking with the Vishwas batches, you're going to be like going with the GATE and PSC 2026 DS and AI. 30th of December, Hindi plus English, DS and AI, and batch number A. You'll be starting on with the database management system. Right, this is what exactly you are having in terms of the batches which are right away there. Right, this is what you're having in terms of the batches which are going to be started on 30th of December. So guys, remember that in the starting I told you there are two kinds of subscriptions by which you can take up the enrollment into your batches, right? That one was a plus subscription, second one is this iconic subscriptions. So guys, the people who will be taking up this iconic subscription, for all of those people, you will be getting these list of the books delivered to your home within 15 days of time, okay. You'll be getting the books of digital logics, operating system, programming and data structures, theory of computation, computer networks, database management system, compiler design, computer organization and architecture, discrete mathematics, algorithms, engineering mathematics and aptitude. Okay. So yeah, everyone, you will be getting up these books delivered to your home within 15 days of time once you took out this iconic subscriptions. So yeah, guys, nothing can stop you from chasing your chase nightly dream. You can get started with no cost EMIs and 0% interest onto the loan, which is going to be for as low as 3,599 per month. Okay, the process is very, very simple. You get the approval in 2 hours, you have the manual paperwork and the flexible tenures also. Okay. And yeah, this is a daily scholarship test which is running. So you can just take this test completely for free and you will win up to 50% of the scholarship for the same. So the duration is 15 minutes and the 15 questions. Okay. So the thing is that you can take this test anytime, anywhere, maybe from your app or maybe from your desktop, and you get the immediate discount based on your performance. Okay, in case you get the first rank, 50% discount, top 1 percentile, 30%, top 10 percentiles, 15%, and up to 90 percentile, 10%. So this is how your complete discount prices have been divided, whatever rank you are getting in that respective case, right? And these are all the Unacademy learners who already cracked it. Many congratulations to all of them over here for the same. Yes, so hi everyone. Okay. What I'm going to do, this is what first of all what I had in to let you know that what Unacademy is offering you. Fine. Now let's move on to our OneNote as of now. Okay, and now let's try to discuss in our topic. Okay, but before that, everyone whosoever has joined in the session, guys, just drop me a hi or maybe yes in the chat box so that I get to know that you are here and we can start in for today. I just request everyone that whosoever has joined in the session, just please drop me a hi or drop me a yes in the chat box so that I get to know you are here and we can start in for today. Yes, everyone, just please drop me a hi or yes. I just wanted to see even how many of you are present. Okay, Harshit, HEBB rule also. Okay, Harshit, what are you trying to say? I just not like really getting. Are you trying to ask about the okay, maybe you are just like to telling me that what topics are left out, right? Is that what you are wanting to do? Is that Harshit? Okay, just give me a minute. Okay, I'll be back. Just allow me a minute, guys. Okay. Till the time, just write down that what do you people like, what topics we haven't studied yet. I'll be back in a minute. Yeah, okay, so I'll just get back to the OneNote for here. Okay, let's do one thing. What I'm going to do, I'm going to start on in detail with the PCA. That's your principal component analysis, right? And then even I remember that a few of the things are there that haven't been discussed up. Like a ridge regression, RIDGE, right? Remember ridge regression we haven't discussed up till now, right? What else? There was one linear discriminant analysis, right? That also we haven't discussed it yet. So yeah, there are a few things that we haven't gone through. So I just want you people in case you people remember anything that we haven't studied yet, you can help me out with the same. And whatever I'm going to remember it, I'm just going to schedule up the classes for covering that same thing. Okay. So I'll just move on to a new section. And I'll just put down the heading for today that we will be discussing. This time I'm going to write it complete. Okay. Principal component analysis. Okay, this is what we'll be discussing up right away. That is the principal component analysis, guys. Okay, now just what comes under this principal components analysis, right? That what exactly we are having up for the same, that I'll be discussing up with you all over here. But yeah, we know that this is a part, this is a type, this is something that we do under the feature selection, right? We just do this principal component analysis during the feature selection. Whenever you are just like working onto the same and everything, in that respective case we study about this thing in the detail, right? Now let's start with this is an algorithm. PCA is an algorithm. Yesterday when we discussed about the dimensional reduction, we discussed about dimensional reduction, right? Now that is not any algorithm, right? What is it exactly? That is a method. Fine, that is a method. But here under this principal component analysis, PCA, this is an algorithm, right? This is exactly an algorithm. And what kind of an algorithm it is? It is an unsupervised algorithm. It is an unsupervised machine learning algorithm, right? This is something that we have for the very first thing, that is it is unsupervised machine learning algorithm, right? Now as I told you, it is used in for your dimensional reduction into the machine learning, right? So this PCA, this principal component analysis, this is actually a kind of a statistical process. Okay, it is a kind of a statistical process which yeah, sure, absolutely right, sure Harshit, I'll just try to do so. Absolutely, I'll try to do so. Okay. Yeah. So what happens? It is a statistical process actually. Whatever the things we are having, whatever the functions we underlie under this, we say that it is a statistical process, and it helps us to convert the observations of the correlated features into a set of linearly correlated features, right? So what happens generally, whatever the correlated features, now what are correlated features are you all are very clear with, because I have discussed that multiple times with you all. So when I talk about the correlated features, so see the correlated features, they all are gathered into a set, right? And now it is being converted to the set of linearly correlated features. So linearly uncorrelated features, right? Whatever the features are not related with each other, in that respective case it is getting converted. Fine. So I'll just even write that down, that correlated features get converted to linearly uncorrelated features. This is what, yeah, okay, fine Harshit, yeah, this is what we just do under the PCA. Whatever are the correlated features, right, those get converted to the linearly uncorrelated features, right? And this is happening up with the help of a orthogonal transformation, right? Like we are just like trying to perform the orthogonal transformation, right? So whatever these new features, what are the new transformed features we will be getting, right? Whatever will be the new transformed features, those we will be saying as your principal component. What are we doing? Like converting the correlated features to linearly uncorrelated features, right? So whatever these new transform features will be, those will be known as your principal components. Okay. So I would just even put down that, but no, that's not such needed as well. So yeah, it's completely okay. Fine, that is what this principal components is exactly gonna be, right? Now, this is something which you PCA you generally use it for the data visualization, for the exploratory data analysis, right, and in the predictive modeling also. Okay, you try to mostly use out this under your predictive modeling and into your exploratory data analysis. Okay, so it helps us to make up the strong patterns from the given data set with the help of reducing the variance. So see, how does it help us to make the different patterns from our stuffs? Okay, Harshit, network glitch was from my end. Oh, okay. Completely okay. I'll just repeat it. So, Harshit, we were talking about that whatever the correlated features which we are having, those get converted to linearly uncorrelated features, right? So now, whatever the new transformed features are there, right? Whatever are the new transformed features, first of all, that we call as the principal components, right? Now, this PCA, this is one of the what most of the popular tools that you generally use in for your exploratory data analysis, right, and for your predictive modeling also. You use it for your exploratory data analysis and for your predictive modeling. For both of these things, you use out this PCA technique. And this is a technique now which generally helps you to draw strong patterns. Okay, generally first of all helps you to draw the strong patterns from the given data set and by the help of reducing the variance. So how does it draw the strong patterns? It just draws that strong patterns by the reducing of the variance. Okay. Fine. Is that okay, Harshit, now? And everyone, is that clear to you till now? Like what it is, what is principal components, what do we have in here, and how do we make the patterns, what it is used for. I just covered everything in a brief, right? Everyone clear with the same? Ankit, ma'am, can I skip machine learning subject for GATE 2023? See, Ankit, machine learning is something which really keeps a lot of weightage as well for you, right? And even it's a lot, you have a lot of toss-up topics which are lying under this machine learning. So see, I won't recommend you to skip the complete machine learning, but what I'll say, maybe you can study machine learning. Yeah, but maybe you can study machine learning. Not every topic, but yeah, according to you, whatever you find are the easy topics, I recommend you that try studying them. Okay, do not completely leave machine learning. Okay, do not completely leave machine learning. Just a minute. Okay, hi Makant, hi, welcome to the session. So my recommendation will be do not leave completely. Just try to study something from that, from machine learning also. Okay, so yeah, everyone clear with the same? Yeah, like whatever we discussed about the PCA yet now, everyone, are you all clear with the same, guys? Okay, now what happens, one more thing under the PCA. There is one more thing which happens, and that is it tries to find the lower dimensional surface. Wherever you will be finding the less dimensions, so it like generally tries to find the lower dimensional surface. Okay, for projecting the high dimensional data to project a high dimension data. Okay, daily tadka, ma'am, are you covered general aptitude part? Okay, daily tadka, I'm not very sure with the general aptitude part, because after this we have to go with the statistics and probability. Okay, so yeah, in case we complete the status probability on time, surely I'm going to cover the aptitude part also. But yeah, in case we're not able to solve this on time, so I can't like say too much onto that particular portion, right? Okay, so let's try to understand, guys, that what are the real world applications of PCA, like into the real world where PCA is exactly getting used out, right? So we generally use up the PCA while you are dealing with the image processing kind of the data, where you require the image processing, movie recommendation system, right? And maybe optimizing the power allocation in the various communication channels, right? So yeah, these are some real world applications for the PCA, which are like image processing, movie recommendation system, optimizing the power allocations in the various communication channels. Yeah, these are a few of the real world applications which are into which PCA is right away getting used. Principal component analysis. Okay, now this PCA is a feature extraction technique, right? This PCA, right, Hershey filtration problem, absolutely right, absolutely fine. So yeah, we were talking about this PCA, right? So it is a featured extraction technique, right? So what happens? So it generally contains all the important variables, okay, and it drops the least important variables. This is what happens under the feature extraction techniques, okay. It is a feature extraction technique, so in that case it is gonna take the important variables and dropping out the least important variables. That what happens under the PCA. Clear with that, everyone? Yes, everyone clear that in this feature, it is a kind of feature selection, a feature extraction technique where it contains the important variables and drops out the least important variables. Okay, Harshit, will we cover numerical portions of PCA? Okay, not right today, Harshit, not right today, but yeah, we will be doing it afterwards. Okay, not right today, but we'll be doing it. Okay, now this PCA algorithm, right? This PCA algorithm, it is completely based on a few numerical concepts. Okay, PCA algorithm is based on some mathematical concepts. Okay, so the very first mathematical concept on which it is based is variance and covariance. Variance and covariance, the very first mathematical concept into which PCA is based on. Next is eigenvalue and eigenfactors. Okay, next is we are having eigenvalue and the eigenfactors. Okay, Harshit, like calculating eigenvalue, vector, normalized eigenvectors, and new data set. Right. Absolutely right, Harshit. Absolutely right. Perfect. Now, I would help you out with a few terms which we generally use up in the PCA. Okay, I'll be helping you out with all of those terms in the details now. Right, that what do these means up into your detail. So I'll just take a new color of the pen And yeah, just before that guys, I just request everyone that guys, please let me know, am I clear on this particular place to all of you? Yes, everyone, am I clear till this place to everyone, like whatever we have discussed about PCA? Are we clear with the same? Okay, Harshit, what about the rest, everyone? Okay. See, so what happens in dimensionality? What is it? It is exactly like whatever are the number of features of the variables which are present into a given data set, right? So it is kind of the number of the features which are present up into your given data set, or more simply you can say it is just the number of columns which are present into your data set. This is what dimensionality means. Right, either, okay, fine, Vivek, thank you for the confirmation. Okay, Arjun, thank you for the confirmation. So see, dimensionality is something where you're having up the number of features of the or variables which are present in a given data set. Number of variables or features which are present in a given data set. Or more simply, you can say it in a manner, it is a number of columns which are present in the data set. Okay, it is a number of columns which are present in the data set. So I'll just write in a simple manner, number of columns. Fine, this is what dimensionality means. So now whenever I say dimensionality, just try to remember this is only what dimensionality exactly is. Okay. Next is we'll be learning about the correlation. Okay, correlation. Now it actually helps us to get in the idea, and even it actually helps us to signify, right, that how are two variables related to each other, right? How are two variables related to each other, right? So in that case, what to have such that if one changes, right, then the other value also gets changed. Right, if there is a change in the one value, so the second value is also gonna change. This is how what correlation is. So I'll just even write that also. It is all about that how strongly two variables are related. Right, this is what correlation is. Now, what happens the correlation value which we are having, that ranges from -1 to the -1 to +1. I'll just write it clearly. -1 to +1. So the value for our correlation, right? Value for our correlation ranges from -1 to the +1. So -1 is something. -1 is going to be occur, -1 will come as a input, maybe as an output, when your variables are inversely proportional to each other. Okay, whenever you are having up your variables, those are inversely proportional to each other, then your -1 value will come, and +1 will be coming when your variables are directly proportional to each other. So I would just say, when variables are, I would just simply write inversely proportional. Inversely proportional. +1, I would just say it is directly proportional. Okay, this is what we have here in terms of the correlation, inversely proportional and the directly proportional terms. Okay. Okay, Ayush, hi, from where to practice machine learning MCQ questions? Okay, Ayush, for that, either you can visit onto the Google, and right, you can just write about there that machine learning MCQ questions to practice. Okay, that is from one place you can do. And Ayush, very soon I'm also going to start out the practice once we are done with this machine learning. It's just two days, I guess, is more there for machine learning. Then we'll be starting on with the practice of the question. So in case you want, you can just join up here also for practicing up the machine learning MCQ questions. And rather you can visit up the Google and just write that down. You'll be getting a lot of kind of questions to solve them out. In terms of the MCQ questions only, you'll be getting a lot of MCQ questions which you can solve in and just practice out. Most welcome. नीरज मैम IQ PDF मिल सकता है? Okay, Neeraj, I am not very sure with the same. Okay, I'm not very sure with the same. I'll just ask our team once now, and then I'll let you know about the same thing. Okay, I am really not very sure with the same. Okay, fine. Let's proceed in everyone, and now we are done with the collation. Let's talk with the orthogonal. Remember, I just took this term orthogonal into this PCA only. I took this term which was orthogonal, right? Harshit, school भी college जैसा होना चाहिए. No books in the bag, only slides या PDF. Yeah, absolutely right, Harshit. But studying with the books is something other like it is also a very good thing, right? Many times you won't get a lot of things under the slides or the PDFs, right? But you get those under the books. And you know, like many people have the habit of having the hard copy of the books and then studying from those books, right? Many people have that habit still, and there are many people who like to study from the books also. So yeah, but yeah, absolutely, these transformations should continue. Everything should be changed up further also. Yeah, right. Okay, let's talk about the orthogonal, like what it is, right? So it helps us to define that the variables are not correlated to each other, right? And hence the correlation between the variables is zero. It helps us define that variables are not correlated to each other. Variables are not correlated to each other, and it indicates that these are there is no such correlation between the pairs of the variables is zero. So I can just write that correlation is zero. Okay, this is what we have under orthogonal. That's right. Absolutely right, Arshit. Absolutely right. Fine. So yeah, orthogonal are something where variables are not correlated with each other and the correlation between the variables are zero completely. Okay, that is what orthogonal is. Next, I talked to you about, I just mentioned up this thing which was eigenvectors. I mentioned out this term a few minutes before to everyone, which is eigenvectors, right? So let's try to now discuss what eigenvectors are, right? So let's say there is a square matrix M and we are having up a non-zero vector V. Then in that particular case, V will be the eigenvector. Okay, if we are having the scalar multiple of V. Again, I repeat, let's say we are having up a square matrix of M. Okay, and we are even having up a non-zero vector V. Then V will be the eigenvector if AV is the scalar multiple of V. So in that particular case, I would just say that eigenvectors are somewhat like we are having, let's say, a non-zero vector which is V. So it will be an eigenvector in that case if the constant value which is A and the value of V, like that is the scalar multiple of V. In that particular case, we will say it is an eigenvector. Okay, so I'll just write that V will be an eigenvector if AV is the scalar if AV is the scalar multiple of V. This is what eigenvectors are. Okay. And last we are left out with the next, that is our covariance matrix. Covariance matrix, right? Yes, right, Vivek. It is going to be transformed by the constant factor. Harshit, orthogonal means collinearity is 0. Perfect. Dash of ma'am echo हो रहा है. Guys, is the voice echoing? Everyone, is the voice echoing? Harshit, can visualize 2D geometry as orthogonality? Means perpendicular means collinearity is 0 and correlation is 0. Absolutely right, Harshit. Right. Whenever like in that the collinearity will be 0 and correlation will also be 0. Fine. Talking about the covariance matrix, guys, this is a kind of a matrix that contains the covariance between the pair of variables. Okay. So whenever we are having a matrix that is going to contain up the covariance between the pair of the variables, in that particular case we will be saying that as a covariance matrix. So I'll just put that down also. I would just write it in this manner: matrix containing the covariance between the pair of the variables. That is what covariance is, right? So when a matrix is containing the covariance between the pair of the variables. Fine. Okay, fine, Arshit. Thank you for the confirmation. Right, everyone. So this is what are a few terminologies onto your like this PCA, dimensionality, correlation, orthogonal variables, eigenvectors, and the covariance matrix. So hey Roshan, hey, welcome to the session. So everyone, am I clear with this all things which I had told you till now into the session about the PCA? Everyone just confirm me out. Am I clear to this particular place to all of you guys? ओके रोशन मैम, कौन से IIT में एमटेक के लिए इंटरव्यूज होते हैं? सो रोशन, इट डिपेंड्स लाइक व्हेन यू गोना क्वालिफाई आउट द गेट, राइट? आपने जो भी जैसे गेट का एग्जाम क्वालिफाई किया, उसके बाद आपने अपना जो भी सब्जेक्ट्स भरा हुआ है, राइट? जैसे कि लाइक यू माइट हैव टेकन दिस like you might have took this data science and AI, right? तो जो भी कॉलेजेस आपके DS और data science और AI के कोर्सेज को होंगे जिन भी IITs में, उन सारे में यू कैन जस्ट गो अहेड एंड हैव इन योर इंटरव्यूज बेस्ड ओवर आपका क्या रैंक आता है, ठीक है? सो इट ऑल डिपेंड्स कि आपका यस absolutely right. It all depends कि how is your rank and what is your subjects which you have taken, ठीक है? It depends on that respective thing. Many people take the statistics वगैरह वगैरह. So statistics वगैरह जो भी MTech की डिग्रीज जो भी IIT कॉलेज ऑफर करते होंगे statistics, उनमें आपका इंटरव्यू होगा. ओके. IIT ओके इंजीनियर, इस बार तो गेट की प्रिपरेशन CSIT की हो गई है, सोच रहा हूँ फिर भी गैप लेके फिर से DSAI के लिए प्रिपेयर कर लूँ. Yeah, absolutely right, engineer. You can surely do that. ठीक है? अभी के लिए what you can do, you can just give out this GATE exam जो कि अभी 1 month बाद आप लोग का आने वाला है. Just give that and then further taking your decisions based over what like ranks you people have scored, what you all have scored. Based over that, then take any decisions that do you want to take a gap or maybe you want to move further with this only. So it depends, right? राइट राइट राइट, एब्सोल्युटली राइट हर्षित, इट डिपेंड्स अबाउट योर प्रोग्राम, जो भी आपने प्रोग्राम लिया है. ठीक है, perfect everyone. So let's proceed in, and now I am going to let you know a few properties of your principal components. Okay, I'm just going to help you out with a few properties of the principal components. So I'll just put down the heading, properties of principal components. Remember I told you in the starting that what principal components are? Properties of principal components. Okay, let's discuss about the properties. Right, yes, Roshan, it happens. Yes. So properties of your principal components. Fine, let's discuss about this in the detail over here, that what are the properties of your principal components. Fine. The very first thing is that the principal component must be the linear combination of the original features. The principal component, it should be a linear combination of original features. Linear combination of your original features. That is the very first property of your principal component. It should be a linear combination of your original features. Fine. The very first thing. ओके हर्षित मैम, आपने DSAI का कर रहे हैं, लेकिन DA में एडमिशन का कुछ बताया नहीं कि वो AI में कैसे होगा एडमिशन. ठीक है हर्षित, व्हाट आई डू ना, आई जस्ट ट्राई टू अरेंज अ सेपरेट सेशन इसके लिए. ठीक है, मे बी इन 3 to 4 days विल जस्ट ट्राई टू अरेंज अ सेपरेट सेशन वेयर हम लोग डिस्कस करेंगे इन्हीं सारी चीज़ों को, लाइक अबाउट द एडमिशन, हाउ विल यू बी टेकिंग एंड एवरीथिंग हम लोग उसी में डिस्कस अप कर लेंगे. ठीक है, so let me arrange a different session for the same. Okay, next is ki the components are orthogonal. It means that there should be correlation between a pair of variables is 0. Second is that we are having the components in the like principal components, those should be orthogonal. Components are orthogonal. That is the other property of PC principal components. Okay. Next is we will be like we have the importance of each component decreases when going from 1 to the n. In the principal components, what happens? That the importance of each and every of those components now it gets decreases out when we are going from 1 to n. It means that one principal component has the most importance. Then n principal component will have the least importance. So I would just write this particular point also, that importance it will be importance of each component, decreases when going to 1 to n. This is what happens, right? The importance of every component decreases when you are going from the 1 value to the n value. So principal component value with the 1 will be having the most importance, and with the value n will be having the least importance. Okay. So yeah, these are a few properties of your principal components that you have to remember, and those are essential as well for you to remember out. So everyone, am I clear with all the properties of your principal components? Yes, everyone, are we all clear like what are the properties of your principal components? Just confirm me out, guys. Okay, fine. Now, what are the applications? Okay, fine. So yeah, applications, I told you all about that. It is used in the dimensionality reduction, right? In the various kind of applications, computer vision, image compression, etc. Right? So like whenever you have to find a few hidden patterns in the data, then also it is used, right? It is used in the fields of finance, in the data mining, psychology, and many more fields. This PCA, this principal component analysis, is absolutely used out. Right, so these are a few things which we have under the PCA. These are a few topics, and yeah, these are the things which we have under this, right? That it is like what exactly it is, right? Then what are the important things, important topics which we have under them, right? Then we have learned about all of those factors in the detail. Then we learned about the properties, right? We even learned about the applications of your principal component analysis. Fine. So everyone, guys, do you people have any doubts of whatever we had studied till now in the PCA, in the principal component analysis? Yes, everyone, guys, are we clear till now about the principal component analysis? Okay, sorry to interrupt. Why are the eigenvectors orthogonal? See, orthogonal, for the orthogonal, what I told you guys, that when variables are not correlated to each other, then when we say that the correlation is 0 between the variables, that is what orthogonal exactly means, right? So now see here, eigenvectors are somewhat that you are having up a, let's say, eigenvector V, and it will be an eigenvector in the case we are having up the value for AV, and that is a scalar multiple of V, right? So see, there should not be any correlation between the eigenvectors, right? Because in case a correlation occurs between them, right, so it might create a problem while solving up your programs, while solving up your problems, and each and everything, right? So that is where we say that eigenvectors are not orthogonal. Sorry, are orthogonal, right? So because there should not be any correlation between all of those respective eigenvectors. There shouldn't be present. Okay. I think it's because the covariance matrix is symmetrical matrix and eigenvectors of symmetric matrix are orthogonal. Fine. Okay. Okay. That is all okay. Soil regeneration, but yeah, there is one factor of the correlation also, right? And you cannot have a correlation value between these eigenvectors. It won't make the correct output for you. It won't give you the correct results, right? So yeah, that is also one of the reasons. And yeah, according to like reason what you mentioned up for the covariance matrix, symmetrical matrix, everything, that is also quite pretty cool, right? It is also true, right? Okay, fine. So yeah, everyone, I just wanted to let you like according to the syllabus which we have under the machine learning, this PCA was the last topic, right? But I guess we are left out with two topics in the between. Three topics. One was your ridge regression, one was your linear discriminant analysis, and one was about the neural network. So like the cross validation techniques, right? I guess these three of the ones we haven't discussed it yet. Right, so I'm not very sure will you be like I hope we haven't discussed these yet, so I'll be scheduling up the classes for all of these three for the further days. That will be your, today is 27, right, 28, 29, 30. Accordingly we'll be scheduling up the sessions. Fine. So after we are done with the same, we'll be moving on to the MCQs as well, and starting with the statistics and probability for machine learning. So clear with that, everyone? First, we'll be covering other three topics which are left out into our complete syllabus for machine learning. Then we'll be moving further with the rest of the other stuffs. Okay, Fine. So in case guys, you people don't have any questions or any queries, does the value of eigenvalue also matter? Yes, absolutely right. So regeneration, the value for the eigenvectors, eigenvalue also matters. Absolutely, it matters out a lot. When you are performing up the PCA, so for PCA, covariance and variance and eigenvalues and vectors, these are the two most important two most important things that you have under the PCA, right? So yeah, absolutely this matters out. Okay, the increase of the values, the decrease in the values, all those things matters out a lot over here, right? Fine. So as I was saying that furtherly we are gonna start on with the ridge regression, cross validation techniques, and then talking about your linear discriminant analysis. So we'll be having first the classes for all of these three, then further we'll proceeding up and working about the same, right? For eigenvector you need eigenvalues. Absolutely right, Harshit, right? So regeneration, which eigenvectors should be important or used to define the new feature? Okay, I mean the value greater than the 1 or lesser than the 1. Okay, see, in that particular case, I would just say that solution, that eigenvectors, those are important for you for defining up the new factors, right? For defining up the new values, those should be less than 1. Okay, many a times it's kind of a lesser than 1 only, so as to get you the results, so as to get you the final ideas. Okay, there is no different eigenvector. Absolutely right, Harshit. Fine, everyone. There can be almost n linearly independent vectors in Rn dimensions, right? Absolutely right, Vivek. Absolutely right. Okay, fine guys. Anything else, or shall we close up the session for today? Yes, everyone. Anything else for today, or shall we close up the class for today? No, Harshit, no. Okay guys, these things we will talk sometime afterwards. Okay, I'll still it's a kind of a so like kind of something which I haven't disclosed it yet to all of you. Okay, so we will be I'll be letting you know about these things very soon, but yeah, you have to wait for some time. Okay, I won't disclose it like that. We'll be discussing about those in a few time. Ritik ma'am, next week is schedule and worksheets. Yeah, Ritik, next week we'll be further moving with your this only. Next week also now we'll be moving on with the same machine learning, and right, if we are done with the machine learning, we'll be proceeding on with your statistics and probability in that particular case. Okay. Okay, solid regeneration. What no definite eigenvector means? Means there exists infinite eigenvectors depends on the calculated eigenvalues. Okay. Okay, fine. So what I'm going to do, I'm just going to close up this session as of today, everyone. Okay, I'll be closing up this class for today. And I will see you all tomorrow at same time 7. Okay, I'll be sure Ritik, sure, I'll be sharing the session with, I'll be sharing the complete list of the next sessions with you all very soon. Okay, so hopefully I'll be seeing you all tomorrow at 7 p.m. but yeah, it might happen that class get a little bit of delay also, because because I have one of the workshops I have to take in for. So if there is any delay, so you people can wait and you can just turn on the notify button. So once I start the class, you'll be getting notified about the same. Okay. So yeah, thank you everyone for joining the class. Thank you everyone for being here. I'll see you all tomorrow, same time 7, with the new things for you all. Till then, thank you everyone. Take care and have a great night ahead, everyone. Okay, thank you. Thanks a lot for joining in, everyone over here.